So cumulative distribution functions, every random variable has a PMF, and if you have a PMF, which is a probability mass function, it is going to have a CDF, which is a cumulative distribution function. What does cumulative mean? You add things together, right? So you're accumulating stuff. So typically we denote cumulative distribution functions as f of x, uppercase f of x, and that would be equal to the probability that x is less than or equal to little x. And the key thing to note here is less than or equal to. Oftentimes people might forget to put that less than or equal to sign, but it has to have that equal sign. Okay, so what does it mean? Well, any ideas? I think we did this last time, the last two problems from the previous class. Yeah, what, please?
So it's like taking the chance it was less than or equal to, less than or equal to length. So you got left. It does say it's.
I see what you're saying. So last time we said out of 7 mornings, or was it 10? I think 7 mornings. What are the chances, or 10 mornings? Out of 7 mornings, 10 mornings, what are the chances, you know, Chris takes at least this many number of, was it frosted flakes?
Say it was frosted flakes.
Frosted flakes, cereal boxes, and at most this many frosted flakes, cereal boxes. So that greater than or equal to is simply at most. So you may ask me, well, we were able to calculate these probabilities last time without even knowing about the CDF. Why do we bother? Well, there are certain distributions for which the CDF is easy to find. So you would get a formula. All you have to do is plug it in the formula, you will have the answer. Does that make sense? So you don't have to evaluate the PMF for every single value and then add them together. You just have a formula for it. Unfortunately, binomial, you don't. You can't sum, or it's very hard to simplify and get the CDF for a binomial. I think there is a derivation and approximation. I have to look it up. CDF has certain properties. This is just one of many cases. We have a discrete random variable that is defined on a finite set, 0, 1, 2, all the way up to n. So the very first property, f of 0. What would f of 0 be equal to? It is just a probability that x is equal to 0. What is f of minus 1? 0. F of n plus 1.
0.
What would f of n plus 1 mean? If you rewrite it, we could rewrite it as probability of x less than or equal to n plus 1. Correct? Then less than or equal to n plus 1 is the same as saying probability x is less than n plus 1, or, which means union, probability x is equal to n plus 1. Correct? X less than n plus 1 is, well, are the two events disjoint? Yes, they are. So probability of x less than n plus 1 plus the probability x is equal to n. Could I write this in a different way? A different cumulative probability less than n plus 1, less than or equal to n. What about that? 0. So that is simply probability of the random variable x less than or equal to n. In terms of our notation, this would simply become f of n. But what is f of n? 1. Good. So f of n plus 1 is 1. What is f of n plus 2? 1. What is f of n plus 3? 1. What is f of n plus 1000? Still 1, right? So beyond a certain point, the function has to be 1. Sometimes we like to write the CDF, using the notation for the random variable itself. By we, I mean me, because it's very formal to write it this way. So for example, if the random variable is x, we can also specify it as f sub x of x. Right? If you just have one random variable, it is redundant. We don't care about writing it this way. But if you have more than one random variable, it helps us to write it that way. Do we agree?
So is that the same as that's the one that we use to calculate for the partial derivative? So is that the same thing that we're going to do here, or is that just something entirely different?
Like partial derivative in the sense.
Like,
oh, I see, you write it as.
big little x is like partial.
Oh, it's similar to that, but we do have partial derivatives, and when it comes to that, this notation is helpful, easy to understand.
But that what we're about to do is not a partial, or
this is not a partial.
Okay, all right.
Yeah. Good, are we clear? Okay. We'll do a simple case of finding CDF, and again, it might seem quite trivial to you as to why we have this function, but in certain cases, we have a formula for the CDF and things get really easy. Later on with continuous distributions, it is the same case. I will do a discrete uniform also. Let's see. Three-sided, is it possible? No. Four-sided, yes. So we have two four-sided dice, and let W be the product of the two outcomes of the dice, and we want to find the probability mass function of W. Okay, so first we've got to know the possible outcomes for X. So X would be, it could take 1, 2 is a possibility, 3 is a possibility, so is 4. 5 cannot happen because the only way we could get 5 is if it is a multiple of 5. So we have a four-sided die, it's not going to happen. 6 is a possibility, 7 is not going to happen because 7 is prime, 8 is a possibility, 9 is a possibility, 10 not possible because it is a multiple of 5, 11 prime is not possible, 12 3 times 4, so that is possible, 13 not going to happen, 14 not going to happen, 15 not going to happen, 16 will happen. Yes?
You learned when you get to this point, writing out the X and then the squiggle and the binomial and numbers.
Yeah.
Okay,
Okay, now repeat that.
can you write down the notation that has the X and a squiggle and then binomial and then the numbers?
So, no, we can't do that.
Why?
This is not a binomial, right? This is an arbitrary random variable. It doesn't fit a category, right?
So PMFs are not only for binomials?
Yeah, it's not only for binomials.
Okay.
There's a think of it this way. Do you have a sibling?
Yeah.
Sister?
Yeah.
Two sisters, okay. Let's say that Y is, one of your sisters. You could say Y is distributed as Mary. Let's say today your sister wore a teal, one of your teal shirts or tops. So the parameter is teal. Your sister distributed means wearing, donning Mary of teal. Does that make sense? And I could specify it because your sister follows, or owns your distribution. But here, there is no such name that I can give for this PMF, right? So it's just a random PMF. Oh, it's not X, it's W. So we have 1 through, the last one to 16. So Pmf is probability of some little w. Oh, that's little w. Looks like omega. Total number of possible outcomes, 16. The only time we are going to get a 1 is if it is 1 out of 16. Getting a 2, we have 2 possibilities, so that would be 1 over 8. Getting a 3, we have 2 possibilities, 2 out of 16, 1 over 8. Getting a 4, 3 possibilities, so 3 out of 16. Getting a 6, 2 possibilities, 1 out of 8. Getting an 8, 2 possibilities, 1 out of 8. Getting a 9, 1 possibility, 1 out of 16. Getting a 12, 2 possibilities, 1 out of 8. Getting 16 is 1 out of 16.
When you do like the number 2, it's 1 times 2 is 1, and then 2 and 1 is 1. But how on 4, like 2 and 2 is just 1. Instead of 2
4 times 1 and 1 times 4. There are 3 possibilities.
and then 2 to 2.
Yeah,
But
4 times
that's
1.
not, because you,
Why are you counting 2 and 2 twice?
because like it's 2 different dies.
They're different dice, die 1 has a 2, die 2 has a 2, so that's a separate outcome.
That's very interesting. She's asking how come you don't count 2 and 2 versus 2 and 2?
Like twice, because it's 2 different 2s, 2 die.
It's like in the same.
You roll the first die, it's a 2. Then you roll the second die, it's a 2. There's only one possible option for rolling the first die to be a 2. Whereas if you're looking at 4, you could roll the first dice to be a 1 or a 4. So that's 2 options for the first roll. And then the second roll, you also have those 2 options.
Do you have 16 possibilities? Yes. Times 1 times 1, 1 times 2, 1 times 3. I just did it for every single case. Out of those 16, how many of them are full? That's a full. So die 1, die 2. So I have 1, 2, 3. So 3 out of 16. Good. Now the CDF, we should sort of have a form of continuity. Going to erase this over here. We have to painfully write this out in this case. There is a reason when I do the graph, it would make sense. When I started the problem, I started with a 6-sided die, 2 of them. That would have been very painful, writing from 1 all the way up to 36. We don't have time for that. So I would like to find the CDF of the random variable W. So f for each of those values. What is f of 1? 1 over 16. what is f of 2? 3 over 16. Who gave me that answer? Why? I'm adding the probability of this to the probability of that, right? Because there's less than or equal to 2. And the next one, for 3, what would we have? 5 out of 16. And for 4, 8 out of 16. Yes, which would be 1/2. For 5, still be 1/2. For 6, 10 out of 16 should be 5 out of 8.
Wait, 5?
Huh?
No. 5.
No, I'm doing the cumulative probability.
Oh, yeah.
Yeah, I'm not doing the outcomes, I'm doing the cumulative
That makes
probability.
more sense. Yeah, because there's no chance that it's still.
Okay, so what do we get for 7? Same as 6, because we don't have an outcome 7. So 7, 5 over 8. What about 8? It's 6 over 8, so we will have 3 over 4. 9, 1 out of 16. 13 out of 16. 10, it'll stay at 13 out of 16. 11, it is going to stay at 13 out of 16. 12, 13 out of 16. 13, it is going to stay at 15 out of 16. 14 is going to stay at 15 out of 16. 15 is going to stay at 15 out of 16. And lastly, 16 out of 16, which is 1. Now, does it make sense that f of 16 is 1? Because the maximum value that we can take is 16. So can't go past 1. If I did f of 19, it'll still be 1, right? Because we don't have any outcomes past 16. So you keep on adding, you will still get 1. So that would also be 1. Are we clear? Now we want to graph this on an exam. I'm not going to ask you to graph, but I would want you to interpret. So let's start with 16. So for any value past 16, it is going to be at 1. And exactly when we reach 16, what is its value? 1. Good. What is the value at 15? It's 15 out of 16. That's somewhere between these two. Do you agree? Yes. What's the difference? But it has to come from that side. So I can't simply put a dot there and just call it quits. Because we want to specify in practice, even though we know that this is going to take discrete values. If someone wants to know, well, what is the probability it's going to be less than or equal to 15.5, you should be able to give that answer also, right? So you will start there and you go that way. Yes? you'll go at the same value until you hit 16, and then you would jump. And for 14, it is the same. Well, so 14, 13, 12, the same point. So that's what we have. Now it would make sense as to why we kind of draw a continuous line, because, you know, there are outcomes here, and this is very generalized rather than giving discrete points. It's easier to quantify and model if it is of this sort, because it's a function. The next one, 12. We still have 15 over 16, 12. Okay. What happens at 11? It's 13 over 16. 13 over 16 is probably somewhere over there, right? Yes. So this is 12 after 16, so 13 after 16 should be slightly above that. Good. And it stays at 13 out of 16 all the way up to 9. So 9 is up here.
Is that open dot on the right?
Yes. For 8, it's 3 over 4. For 7, it is 5 over 8, and it is the same for 6 as well. So for 5, it is 1/2. For 4, it is 1/2. For 3, it is 5 out of 16. 6 out of 16 is over there, so perhaps slightly less than that. So 3 out of 16, or 4 out of 16 would be 1 over 4, which is right here. So 3 out of 16, slightly above. Well, below is not bad. Bad algebra. And for 2, it is 3 out of 16, so slightly above. So it's 1. It's 1 out of 16. So it's probably below here. Just an approximate picture. And after that, B0, there you go. Yeah. understand this picture because later almost connects to when we do continuous distributions, it will make better sense, hopefully. It should make sense now. There is a specific term in calculus for a picture like this. Yeah. Well, piecewise function, okay, that's one. We've done it in algebra too. In terms of continuity. Piecewise continuity, what? In terms of continuity, let's say I want to know. Yes, that is discontinuity, but in terms of continuity, let's say if I want to find f of a, you know the value. Aha, right? Is it f of a plus or is it f of a minus? Enlighten us, Chris. What is this 8 plus and 8 minus you speak of?
Depends on which side of the 8 you're talking about. Which way do you derive?
Is that how you explain in calculus? Depends on which side of 8 you talk
I took
about.
calculus like several years ago. I have no idea what it's in, how to explain calculus.
Fine. Sydney? No.
Yeah.
No, okay.
It's a limit.
Limits, right? So how would we write f of a? Do we write it as the limit from the left or the limit from the right? It's from the right. So to one-sided limit, so limit as w approaches 8 plus f of w, and that value would be, this looks over it. Yeah. So it is a jump discontinuity, I agree. Piecewise function, I agree. So each of these values, you evaluate them as you come from the right. So this entire function is exhibiting this behavior for all values in its support. So there is a name for this function. Do you want me to repeat that? The graph that we drew is the CDF of the random variable. Do we agree? Yes. So the support of this random variable is 0, 1, negative infinity, I want to put it that way. All of those up to 16. And for every value in its support, this random variable satisfies that condition of limits. You know, anytime we evaluate a cumulative probability, you're actually evaluating the limit from the right. And the function satisfies that condition for every single point in its support. So what function is this? There's a name for this. If it only satisfies from one side, but it is continuous from one side.
A step function?
Step function. It is a step function. I don't disagree with that. When did you guys take calculus?
I was doing dual enrollment. That was years ago. Like,
Joe, make me proud. We went over this.
I remember supposed to learn last year.
Okay, how about this? What is a continuous function? A function that is continuous everywhere. How is that related to its limits?
The left limit exists, the right limit exists, they have the same value, and it matches the function's value.
Wonderful, Benton. Now tell me, what is the name of this function?
Sorry.
Now you can tell me the name of this function. Left limit does not exist, but the limit doesn't exist.
Continuous one on the right.
Okay, so continuous from the right. So finally, we have an answer. This is a right continuous function.
Yeah.
So every single CDF, discrete, continuous, doesn't matter, mixed. The CDF must always be right continuous. And not only that, you should be able to see another behavior in terms of the function. It is exhibiting a behavior step that is correct. So it's going, it's like a stairway to heaven. So we have a name for this. The function keeps doing this. Yes. Huh? Okay. What? So how about this? Maybe the jumping part is confusing. I'll do this. Increasing, okay. So it's always increasing. What is the difference between monotonically increasing and increasing? Or in other words, non-decreasing function and an increasing function. You guys are giving me these looks. Monotonically increasing versus, let me simply say increasing or non-decreasing, specifically non-decreasing.
Decreased by a set of connected points. But then there's also figure out.
Right, so okay, I'll draw two pictures. That's one XY plane. Another. Good. Of the two, which is monotonically increasing? What? Which one? The one on the left, right? Monotonically increasing, strictly increasing. This function, poorly drawn, this is what I meant to draw. Would we consider that increasing? But is it strictly increasing? No, so it's not monotonically increasing. But can I call this function as non-decreasing?
Yeah.
Yes. So when we say a CDF is increasing, we are being very specific, and the term has to be non-decreasing.
So would it be wrong to call it increasing, or are we just being more specific if we say non-decreasing?
We're just being more specific, because there are cases where it is going to be monotonically increasing, but strictly speaking, it is a non-decreasing function. Monotonically. So properties of CDF. Below the smallest point in the support, the value of the CDF must be 0. Above, for all values, it is 1. The function is right continuous, and it is strictly non-decreasing, but we can call it also increasing, because in most cases, the CDF is just increasing. Does that make sense? Good. In this case, is the function from a strict sense increasing or is it non-decreasing? What? Non-decreasing, very good. Case. A box contains 7 pills, 4 of them are sugar pills and 3 of them are poison pills. Johnny is asked to pick 3 pills, 1 at a time. And Johnny doesn't take the pills right away. He must take all 3 pills once he selects them. So let X be the number of poison pills that Johnny picks. I would like to know the distribution of X, notationally speaking, the Pmf of X, the CDF of X in tabular form, and what is the probability that Johnny dies? Give it a try. So there are multiple, well, there is one main reason as to why I picked this problem, because I want you to think like a statistician at this point, not just like a mathematician. What do I mean by that? Well, you read this problem, some of you jumped right away to this, started writing out all possibilities, you know, started writing SSP, right? SPS, PPP, and SSS, right? Correct. And this is okay, but the problem here was you simply counted the individual outcomes and added them and called it as A. But that's not the case here because we have 3 pills in order and he's taking 1 at a time without replacement. So you would go from 7 to 6 to 5 and so forth because it is without replacement. So the total number of ways cannot be 8 in this case, and it is not 8. Sure, you could sit and write every single possibility. That's one way of doing it to get the total number of ways. If you want to do that, go for it. Or if you want to be purely mathematical, and if you are a combinatoric quiz and you just want to use counting, then count the number of ways in which you could, you know, or the total number of ways in which you could pick 3 pills out of 7, and then you specifically look for a number of ways in which you could pick, you know, 0 poison pills, 1 poison pill, and so forth. So the notation that I was looking for is to read the problem and understand if it follows a specific distribution. That is what I mean by thinking like a statistician. The first thing that I would do when I encounter a problem or in practice is to see if this follows or the conditions for a known distribution. And if this goes beyond just, you know, this class, goes through all of statistics, both frequentist and Bayesian. So the moment I read this problem, 2 things would come to mind. Well, I have total 7 pills. I've got 4 of them sugar, 3 of them poison. I'm picking 3 pills 1 at a time. So independent trials. And after Johnny picks all 3, he's been forced to swallow. If that is the case, the first thing that should come to your mind is binomial, right? So we have n trials, which is 3. You have a probability of success, which is picking a poison pill, failure, picking a sugar pill, and you have those probabilities. But the issue here is it is done without replacement. Each time Johnny picks a pill out of that box, the count reduces. So an experiment that's similar to binomial, but it is done without replacement, will follow what distribution? Hypergeometric. And what is the notation? The last one is the number we pick, which is 3. Yes. The first one is the item of interest and the number that I picked from that item of interest. I am interested in poison, awful band, except for one song. Huh? Again, I like the new one. The next one is 4. And last time I showed you how to do this using your calculator. As long as you know the formula, you can evaluate all values using the calculator. So what is the support for x? The support of x? 0. What?
0 and 4. 0 to 3.
3, not 4. Right, the item of interest is poison, so there are only 3 poison, excuse me, 3 poison pills, and we have 3 cards. The PMF, you could plug it in the formula, and you would get possible values of x, 0, 1, 2, 3. And the probability x equals x, if you plug it in the formula, you would get good. What is the CDF of x in tabular form? I specifically called it tabular because you can't come up with a closed form in this case. Binomial, you can't there either. So x, we have 0, 1, 2, and 3. And probability of x is equal to x. What is for 0? For 1? 2? 3? 1. 4? 50?
Shouldn't it be x is less than or equal to x?
Thank you. I should have just wrote it as evidence. How about negative 100? 0. Okay. Looks like you've got the point. Now, lastly, we want to find the probability that Johnny dies. Well, let's see how good it's going to work out for him. Johnny's death is certain as long as at least one of the 3 pills that he took is a poison pill, right? Because as Stacey Benton, right?
Yeah.
Benton asked me, is 1 pill good enough to off Johnny? Absolutely. So we're making him take 3 by either 1, 2, or 3. Johnny's done. So all we want to find is the probability x is greater than or equal to 1, right? Of course, this is simply 1 minus probability, x is equal to 0. right? And we have something called the complementary CTF. I don't want to mention it in detail now. I think everybody talks about it later. But this is related to that. So 1 minus the probability, 4 out of 35. Which is 31 out of 35. 89% chance, approximately, the exact answer happens to be 88.57% chance. So there is a very high chance that Charlie is going to crow. But does that make sense though? Right? Now, last time we talked about geometry, and we had 70 frosted flakes and 24 fruit loops. Yes. And we looked at 10 mornings and we came to a conclusion that it's more likely for them to pick, for Chris to pick frosted flakes because there are more of frosted flakes compared to fruit loops. Yes, that was our reasoning. We agreed with that reasoning. Why does it not apply here? Shane?
He's taking multiple pills, he's not just taking one pill. If you're taking one pill, then he would be more likely to get a sugar pill than a poison pill. But because he's taking 3, he's taking that risk 3 times instead of just 1.
Very good. So even though I have 1 extra sugar pill compared to a poison pill, we are forcing him to choose 3 pills and maybe he can take all 3 poison pills, which would mean his risk is going to go up.
And it's not going to be replacement. So as soon as he takes out that hypothetical first sugar pill, it's even. And if he takes another sugar pill, then it's more likely that it's going to grab a poison pill.
Right. And that was my second point. In terms of how close they are to each other would also make a difference. It is like saying a 50-50 chance with a binomial. Does that make sense? If you have a 50-50 chance in a binomial, you would have perfect symmetry on both sides. Or excuse me, perfect symmetry, which implies, equal values on both sides. Does that make sense? So the primary objective of this problem, even though we like counting, even if you like counting, you can do counting, but the way to think like a statistician is to look at an experiment or a study and see if you can associate it with something you already know. So if you know something already, you have the formula, you have everything, and you can make an inference right away instead of writing everything out. So that is a phrase that I would use quite often in this class, thinking like a statistician, so get used to it. Okay, that is a good place to stop with this.